you've got a tangent, and this is this line here that has been drawn. And you're told that the point P is the point 0, 2. So this has got a coordinate here of 0, 2. And the tangent goes between P and the point A. The equation of this tangent is in the form y equals mx plus 2. And in part 2, you've got to work out what that equation is. And in part A, you've got to show that the x coordinate is equal to this. But we're interested in this second part here, that a second tangent is going to be drawn. So of this second tangent that is going to be drawn, we're going to be looking at this point B. So we're going to have another tangent drawn. So that tangent must be down at the bottom here, where point B will be touching down here. And you're told that the equation of this tangent is in the form y equals nx plus 2. So it goes through this point here, P. And n is going to be less than 1, so it's not got a steep gradient as this first gradient. And the question wants you to find the exact value. So this word determine means work out. The exact value, that means give your answer in third form or as a fraction. The value of tan of APB. So the angle between A, P and this point here, B, that's going to appear. So you've got to work out this angle in between here. And this will be worth 4 marks in the exam. Now in part A, you've already worked out m squared plus 1 times by x squared minus 10, lots of m minus 1, lots of x, plus 40 is equal to 0. So we're going to have to use that equation to help us work this out. And in part 2, you should have worked out that y is equal to 3x plus 2. Again, we're going to be using this information to help us work out the angle tan of A plus B, APB. So our key facts. Draw yourself out a diagram, or on the diagram that is given on the exam paper, draw in the extra lines. So draw in this second tangent here and draw down the angles that you need to work out and any measurements you think will help you along the way. You're going to need to complete the square on this equation here to be able to work out the radius of the circle. So the radius of this circle is going to be really important to us. You're going to have to work out the length of the line. So that will be the length of the line A to P you're going to have to find out. And you do that by subtracting the x coordinates and squaring them, and the y coordinates subtracted and squared, basically using Pythagoras' theorem between two coordinates to work out the length of the line AP. Then you need to know, using normal trigonometry, that tan of an angle is the opposite divided by the adjacent, so normal right angle trig. And then using double angle formula, you'll need to use the formula tan of 2 theta is equal to 2 lots of tan theta divided by 1 minus tan squared theta. So these are all the formulas you're going to need to use to be able to answer this question. As I said, we're just looking at part B here, working out the exact value. Press pause, have a go at working out the answer using the key facts that have been given here, then press play when you're ready to hear the answer. Okay, great work. Hopefully you've managed to come up with an answer, and great work if you have done that. So to start with, you should have drawn in the tangent. This is the point here, B. And you can draw the radius, and this will be the distance from the centre of the circle to the edge. And consequently, when you've got a radius and a tangent meeting, you should know your circle theorems from GCSE, but you have formed a right angle triangle. So you can see I've formed a little right angle triangle here. So if I can work out the length of my radius, if I can work out the length of AP, then I can work out this angle in here between AP and C. And the question wants to know tan of A to P to B, so tan of this angle in here. So you've got to work out the tan of the whole angle at the bottom, but to start with, we're just going to work out tan of this top angle. Now, there are alternative methods to do this. It is personal preference as to which way you choose to do the question. To start with, we know that P is the coordinate 0, 2, and we're going to work out this coordinate here, A. So to find A, we're going to use this equation here that's given in part 1, m squared plus 1 times by x squared minus 10 bracket m plus 1 times x plus 40 all equals 0. And we're going to use the gradient of this line here, y equals 3x plus 2, which you've worked out in part 2. So the gradient of this line is 3. So if I substitute 3 into this equation here, you will be able to see that I get 3 squared plus 1 times by x squared. So that's 9 plus 1 is 10 lots of x squared, minus 10 times by 3 plus 1. So 3 plus 1 is 4 times 10 is 40. So minus 40x plus 40 equals 0. From here, these are all a multiple of 10, so I can divide each of these numbers by 10, leaving me with x squared minus 4x plus 4 equals 0. Now this question shows detailed reasoning. Now that means if you type this in on your calculator to show the answer, you need to show you're working out. You should spot that this factorizes into the same bracket, so x minus 2 all squared or x minus 2 times by x minus 2, whichever you prefer to write it as. Consequently, there is one solution because you have got a circle and a tangent meeting, which means you have got one solution. So we would expect to see this repeated root here. And that means my solution for x is a value of 2. So x is equal to 2. So that is the x coordinate of point A. So that comes 2 across. From here, I now need to work out the y coordinate. Now it's easier to use our answer in part 2 because y is equal to 3x plus 2. So x is 2, so 3 times 2 is 6, plus 2 is going to give me 8. So that is the coordinate up here of A, the coordinate to 8. So we're going to use this information here for coordinate for 0, 2 and the coordinate for 2, 8 to work out the length of the line between A and P. Now we have got the length of AP. This is what we're going to be trying to work out. So we've got these coordinates and we're going to use the formula here for the length of the line. So this is subtracting the x coordinates squared plus the y coordinates squared subtracted or added together, and these x coordinates subtracted and the y coordinates subtracted. So I've got 2 take away 0, so this 2 take away the 0 for the x's, so that's going to be 2 squared, which is 4. Then the y values, 8 take away 2 squared, so 8 take away 2 is 6, so 6 squared is 36, plus 4 is 40. So I've got AP is root 40. Root 40 is the same as root 4 times by root 10. Square root of 4 is 2, so that is the same as 2 root 10. Now I know the length AP. I now need to work out the distance A to C. So this is the radius of the circle. So the easiest way to find the radius of the circle is to complete the square on this equation here. There are alternative ways where you could put a tangent and a radius, or you can work out the centre of the circle and then work out the distance of the line. But there's not much point when you can work out the radius from here. So by completing the square, we take half the x coefficient, so half of minus 10 is minus 5. Then we always take away 5 squared, which is take away 25. Then we halve the minus 14, which gives me minus 7. Then it's always take away 7 squared, which is take away 49, plus the 64, which was on the end, is equal to 0. If I rearrange this and put this equal, so the numbers go on to the right-hand side, I've got minus 25 becomes a plus 25, the minus 49 becomes a plus 49, and the plus 64 becomes a minus 64. So 25 plus 49, take away 64 is going to give you 10. So the radius of this circle is going to be root 10. So this is x minus a all squared plus y minus b all squared is equal to r squared, where r squared is going to be 10, so the radius will be root 10. Now I've got the length AP and I've got the radius. So I've got this distance here, which is the adjacent, and the distance of the radius, which is AC, which is the opposite. I'm going to use this formula here for tan theta is the opposite divided by the adjacent. So the opposite is root 10 divided by 2 root 10. The root 10's cancel, leaving me with a half. Now I know tan theta, that's this angle in between here, between A, P and C. Our question wants us to work out the angle APB, so A to P to B. Now that is double what we've just worked out. So it's 2 lots of what you've just found. So tan of APB is going to be tan of 2 lots of theta. Now using the formula for the double angle formula, tan of 2 theta is 2 times tan theta divided by 1 minus tan squared theta. So 2 times by tan theta, where tan theta is a half, divided by 1 minus a half squared, because that's tan theta all squared. So 2 times a half is just going to be 1. 1 minus a half squared, so a half squared is a quarter. 1 minus a quarter is 3/4. So I've got 1 divided by 3/4. So tan of APB is equal to 4/3, which is the angle you're trying to work out. Give yourself a big tick if you got this correct. Great work. That will give you 4 marks in your exam. There are alternative ways to work this out. You could have looked at the triangle between A, P and B and used the cosine rule to work out the angle in between here, and then use trigonometry to then work out tan of the angle. But this is the quickest way to get you to the answer. But there are alternative ways. The mark scheme on this question shows M1 is a method mark for getting the radius and the distance from P to C, or working out that P to A and P to B are the same, which is 2√10. You also get an answer mark for getting that tan of half of APB is equal to a half. You get 1 method mark for getting down for using the double angle formula for tan of 2 theta, or tan of APB in this case. And then your last mark comes from working this out. And that gives you the 4 marks in the exam. If you found this video useful, please share, like and subscribe so we can all get great at math.